Timber Talks is brought to you by WoodSolutions. Stay up to date with the latest in timber, the building material that is strong, safe and sustainable. Here is your host, Adam Jones.
Hello everyone, welcome to the opening of Season 4 of WoodSolutions Timber Talks. So over the next 4 episodes, we've got some really exciting content for you because now we've got over 50 episodes. We're going to go back through the archive and get the best bits around certain topics. And today we're going to be talking about innovation and technology and going through and hearing from 8 different speakers who are all real leaders and innovators in different ways throughout design and construction industry. So without any further ado, we'll get into the first segment. First off, we're going to be hearing from Michael Marks, who's the founder of Katerra. So we're going back to Season 2, Episode 1, and he'll be setting the context with some of the inefficiencies, or as he'd say, sickness in construction and areas for improvement. Then we're going to be hearing from Michael Green, who was Season 1, Episode 15, and he'll be continuing on this theme. We'll also hear from Adam Strong, who was all the way back in Season 1, Episode 1, who started off Timber Talks, and he'll be talking about the opportunities in having a manufacturer or supplier engaging early in projects. And finally, in this section, we'll be hearing from Karim Khalifa, who's from Google-owned Sidewalk Labs, on the importance of cost certainty for driving innovations.
Yeah, I think everybody understands what an inefficient process it is, and there's a reason why it's inefficient. And when I first started the company, it took a while to figure this out. But basically, you have architects, engineers, general contractors, and subcontractors, and all of those parties are cost plus. So none of them have any incentive to take cost out, and so they don't. It's not a surprise, because if the costs go down, they just make less margin and less dollars. And so they don't, everybody's actually invested in the system of being inefficient. So we came to the conclusion that the only way we could fix that was to do all of that ourselves, because then we have the incentive to take costs down, because if we take costs down, we win a bunch of business. So it's pretty straightforward. But it's hard to do that. If I can talk a little bit about, just drill down a little bit here on the cost plus, let's take the engineering side of things. So engineers are basically consultants, and they're not paying for anything they design, but they're on the hook for safety. So they have no reason to try to optimize the solution. So every project is over-engineered, like every single project is over-engineered. And I understand why that is. I think everybody can understand why that is. So, but again, if you're us and you put all this stuff together, we're incentivized to optimize things. Not, of course, not to be not safe, but not to over design or over engineer either.
Mm. And you've also been a previous interim CEO of Tesla a while ago. So you said you were building a global supply chain like you did in the electronics industry. What other things unique from the automotive industry can be taken in other things for construction as well?
Yeah, I think it's very similar. In fact, when we hire for our business, our rule is hire from electronics manufacturing or automobile manufacturing. And the reason is you have mass customization, right? I mean, you can get on a website today, you can order a car, you can pick all the different things you want, but you can't change some things. And that's an industry that's been around for a long time, has really optimized it, as have the electronics industry, is really optimized to take cost out and yet still allow some choice. And so we use both of those industries as models. Mm.
So mass customization, and now in construction, how are you specifically looking to? Because right now, I'd imagine every building we do it singly in one time, every single time. If I'm as an engineer, if you're designing a beam, you design a single beam every single time for every single project. So
right.
How can we remove this from the process?
Well, I think that's a great point that you make, and it's one that I laugh about all the time. Because my partner, who is a third generation multifamily developer, it was his idea to start this company, he said this in a way you'll appreciate. He goes, we're 50 years into this, and every time we start a new project, we start it as though we had never built one before, which is exactly the truth. Right. Yeah. The other way I talk about it is, you look at architects, and they design a building that has never been designed before, has never been built before, and will never be built again, which in the electronics industry, we call that a prototype. So that's obviously not going to be optimized. What's interesting about it is that most people think when they hear that we do off-site manufacturing, what they call prefabricated, some things we do modularly, they think all the buildings will look alike, which nothing could be further from the truth. I mean, that suggests we don't have brains. We can't figure out how to take some of the same things and use them again and again, which is what we do. Another big moment for me was when I first got into business and I went to visit some architecture firms. And I'm walking around these architecture firms and I'm watching hundreds of architects designing 2-bedroom apartments. And I'm going, a computer can run through every 2-bedroom apartment that's ever been designed since the dawn of time in about 5 seconds. Yeah. So why are there thousands and thousands of architects around the world redrafting 2-bedroom apartments? Makes no sense. So we get rid of all that.
Well, it's funny. I'll use a funny analogy, but if you think about a residential project that has 300 toilets in serving 300 residences, right? The cost of a toilet is probably $8-9 at its origin in the manufacturer. But the way it works on the construction site is that before the toilet reaches the job site, it passes through, a distributor's hands, and then the subcontractor's hands, and then eventually the contractor, and then gets on site, then the developer marks it up. And by the time the consumer gets the toilet in their bathroom, it's probably cost them $120. Well, that value shift for any product in the built environment is enormous, and there's no real value in it. It's simply passing hands. So when you start to rethink that, it means you start looking at vertically integrating a company that says, well, instead of that, why don't we build our own toilets? Why don't we make our toilets better, make them cost, maybe they cost $20 to manufacture, but now we can sell them to the consumer for $30, not $120. That's the kind of thinking that comes when you don't see the limitations of scale. And that kind of solution is the way you ultimately really invest in innovation, invest in more sustainable solutions, and can provide much more affordable solutions. That can apply to wood products, that can apply to lighting fixtures or doorknobs or toilets. It doesn't matter. It's once you bring all of those things together, it has a massive impact on the cost of things. And, to really to make a more sustainable planet, it will always come down to being more cost effective than the alternative. People will not, I think, unfortunately, all history has shown us that people will not pay more for sustainable solutions, or the vast majority of people won't. So you have to find ways to make sustainability cost competitive. And that means rethinking, as I say, at scale.
So this whole process of design for manufacturing and assembly, it seems to be quite different to what traditional construction and approaches have been. So with this new approach, what things should people be taking on board to work well with this new paradigm in design and construction?
Oh, look, the obvious thing where we can add more value, but really where any builder and particularly any manufacturer can add more value is to be involved in the project from day one. So we've seen a real shift over the last 3-4 years where we do have clients coming to us earlier and earlier in design or planning or even conceptual design and getting our input. And there's really no need to lock us into a project early for us to put input into a project, because really a lot of this advice would help and make any project efficient to suit a lot of different systems. So if we have a client who comes to us quite early, and we have a number of projects right now where we've been really quite lucky enough for a client to come to us with their architect on day one with no concept and ask for some parameters around what would best suit our solutions, and we can add a huge amount more value, and they'll get a better cost outcome, and even program and less waste and a lot of different things. It'll be a much greater outcome for the project. So getting a manufacturer involved very early in design has huge benefits to a project.
We've been speaking a lot about ways to add value to our buildings, and can we simultaneously make them more affordable? Can you talk about how we can achieve affordability at the same time?
Yeah, so we think the whole concept of certainty for the developer or landowner is a big way to drive down the cost for the building. So if a developer knows that they can get this building delivered and built in a certain time frame that's very exact, and doesn't have all these site problems where the project timeline can get away from them, and if they know the materials are all available because they're all coming out of a factory, so that's very predictable, and if we can price all those materials exactly the way that the factory can order them, we now create this whole environment of certainty. When you create that, the owner now has a much better financial picture of what he can deliver, and it enables him now to take on things like a higher percentage of affordable housing. Obviously, there's incentive programs in all cities around the world to promote that, but I think now the formula becomes a lot more certain, and so people will be willing to take a little bit more, step into it a little bit more, and take some of that responsibility on.
In this next segment, we're going to be hearing from Paul Kremer about the fourth industrial revolution, and Karla Fraser all about virtual modelling and how she used it for Brock Commons to achieve productivity gains.
The fourth industrial revolution pretty much is the concept at the moment. Having toured the US in 2018, thinking they are the be-all and end-all of integration and technology and wizardry that's surrounding information technology and computer integration into things like manufacturing. The reality is that they are no further advanced than what we are. And using very simple things like platforms that Microsoft would offer to be able to design, counters to count the amount of widgets that are going through a production line, for example, is considered, part of this integration and this technological advancement. But I think the main thing that sort of conjures in our heads is this concept of Internet of Things, which is a real thing. There are legitimately, devices that can stick on the side of machines and count the amount of widgets you produce. It can tell you how efficiently you're doing it or not. And there are people that have user interface designs that, plug into some sort of computing system that draws out data from machinery. Of course, in the advanced manufacturing sense, there's usually a computer-graded integrated system, such as the one we had at XLAM, which helps control machines for the production of building elements like cross-laminated timber. But by and large, it's actually quite an anomaly. Many people haven't got it right yet, and some are just at the start of their journey, not the end of the journey. So it's a bit of a misnomer.
And seems like a bit of for those who can tap in and utilise and understand these new technologies, there might be big opportunities on offer. So you mentioned the Internet of Things. How does that link to, say, a supply chain, a practical use within the supply chain of timber products?
Again, I think that there's a bit of a misconception about what the Internet of Things is. Anything that hangs on the internet, whether it be a mobile device, a computing system, etc., is part of the Internet of Things. And so it really, again, is quite amorphous. But to bring it back to something that's more concrete, the Internet of Things could have computer systems that have technology that's in them, for example, software, tracking software that can be used for file sharing between peer-to-peer or computer-to-computer. Intranets, internet is all part of this ecosystem. And I think what's coming out of this is using the various technology platforms such as blockchain that link hardware sources together and then have a distributed way of managing information exchange is really where the technology is starting to move forward. BIM is another concept which really looks at taking Internet of Things items and bringing them together in a coordinated way, much like a concert and a conductor, to fashion the way that buildings are delivered. So there's this sort of genesis of things coming out of Internet of Things.
Absolutely. I know that one of the pieces of technology where you really pushed the limits was the virtual modeling, and
amazing.
yeah, it really was. And even though it was still a couple of years ago now, I haven't seen anything quite like it. Can you tell us what kind of virtual modeling you did and the process and how it improved the productivity for the project?
It's a lesson learning thing. So we did the virtual model. So what we normally would do before we even started virtual modeling is we do a method statement. And the method statement is an identification by the trade of how they're going to actually produce the work that they're going to do. So they tell you, I'm going to pick up this panel, then I'm going to pick up this panel, then I'm going to do this, then I'm going to do this, and this is my sequence of events and how it's going to happen. These are the safety procedures and everything we're going to put into play. And ironically, on the Mass Timber project, the first virtual model we did was the concrete. It was the concrete 2 towers. And it was after reading the method statement that we realized there was going to be a major problem with it, and they couldn't understand it. They had developed the plan, and they just couldn't see what we could see in the plan as critically wrong. And then we actually did the plan in a virtual. We took all the pieces and we virtually modeled how that installation plan would go in on a time delivery on the virtual model, and they could see it immediately what we were talking about. There's a problem, you're going to trap people in this place, and that's going to be a big deal. And after that, then we started to smooth out this process, and then we started to realize, well, maybe we're going to have other problems. We're going to have openings that we need to create. We're going to need to have extra space for things like safety platforms, and if something goes wrong, how are we going to rescue somebody? So that actually evolved a whole different language of conversations that for the entire team and all of the trades of, well, this is how we're going to do it safely. These are the things I need to safely do my work. And now everybody could understand what we were doing, right down to the detail where they could look at the virtual model. We were really cool about it. We put the model right online and said, you know, we're not keeping this information for ourselves. We believe really strongly in sharing information out to everybody. When we learn something really impressive, we want to share as much as we can because we want to promote the industry, not just ourselves. And by sharing it on YouTube, it allowed the trades to actually, 1, show off to their families about what they were up to, and 2, it allowed them to actually understand their schedule right down to the labor detail, which I think is really fascinating because it's one of the lost communication skills. Usually your project managers, your superintendents, maybe your foremen all have really awesome schedules. The detail, 3,000, 4,000 line items, we know exactly where everything's going, but we don't translate that conversation down to the people that are actually doing all the work. And by doing a virtual model, we didn't have to have daily briefs to that level of detail. Now they could actually see the daily brief because it was day 1, 2, 3, 4 of that cycle. They could look at the day of the cycle and go, oh, well, at the beginning of the day I'm doing this, the middle of the day we're doing this, and at the end of the day, if this isn't done, we can't start the next day. So it really helped communicate that right down through everyone in the site, right down to the guys that were cleaning up the site at the end of the day. And it opened up a really interesting communication, and everybody really enjoyed being a part of it because now everyone feels like they're part of a team. Now it's not management at the top and people at the bottom. It's now we're an entire team and we're actually all communicating like a team.
Mm. In this last segment, we'll hear from Richard Maddock, who's an associate partner at Foster & Partners, on the digital design and potential of using computational design with things like parametric modeling to improve the efficiencies up front. Following that, from Christophe Sigrist, who's a professor at Bern University in Switzerland, on robotics. And on a very similar theme, we've got Ola Skoglund to finish off the episode. And he's from Randek, and he'll be talking about innovations in robotics and more specifically the potential with new robotic systems like the zero labor system.
Yeah, that's an interesting one with digital design. So personally, I came to design in an interesting and unusual way because most people I know started out in the architecture or engineering world and then discovered computation. Whereas I started out in the computation world and then discovered architecture. So for me, I I find it difficult to separate the two. I see the computation side of things as just a sort of tool that I have to use when I'm designing things. And for the cutting edge of what we're doing, we're now looking at machine learning and things like that. I think it's been a little bit overhyped so far. And, some people sort of promise the world with what artificial intelligence and machine learning can do. But we've seen some projects and research projects that have proven their usefulness. And so we did this research last year and it's continuing this year. And there was a paper presented at the NeurIPS conference in December last year. And what we did was we wrote a neural net that learnt how to model the CFD for wind flow. So we do quite a lot of, urban scale master plans. And, when you have buildings and towers and whatnot, you need to know how the wind flows and where it goes and make sure that people aren't blown off their feet at ground level. Doing the CFD to figure those things out can sometimes take up to a week to run one simulation. So in that sort of paradigm, when you're designing and trying to make a change and thinking about where things can go or should go or could go, if you have a week's lag between what you do and seeing the effect of it, that obviously reduces what you can explore. Your design space is limited. But with this tool that we wrote, this neural net learnt how to do CFD very roughly. It was maybe 90% accurate, but it meant that we could run those CFD tests using this neural net in almost real time. You would get feedback in about 5 or 10 seconds. And this is very valuable because then as designers, you can play more with massing and layout and the urban design and, the built fabric. And you can have immediate feedback on how that affects things such as wind flow. And then what's really interesting is because you've then set up this software process that does that, you can then run it backwards. You can then say, all right, here's the wind flow pattern I want. For example, here's a park. I want that to be fairly calm and quiet. And here's a road. I want that to be a bit more windy to clear some fumes maybe, whatever you want. But you can dictate, here's the wind flow that I want. Now you tell me what layout of buildings results in that wind flow pattern. And this is where machine learning can be a creative thing. And it's just, a very narrow spectrum of creativity, a very narrow spectrum thing. It's just on wind flow CFD, but it speeds up the design process so you can explore more possibilities. And it also provides a creative outlet that you can run the process backwards and maybe come up with things that you wouldn't have thought of or expected otherwise.
So that's on machine learning CFD, which we're using machine learning to really unleash the creativity of the designers and maybe get more optimal outcomes. If you look at other industries like the automotive industry, they're using machine learning or artificial intelligence for driverless vehicles and things like that. I guess the people who are maybe potentially getting ahead of themselves, who you were referring to before, might be the ones who, think eventually structural design, maybe costing, maybe all aspects of the design might be embedded within software that uses machine learning. Do you think that in the future that this will reach this point? And if so, how will the designers in those different professions need to adapt to unleash their creativity, like you were mentioning?
Yeah. If that point were to happen, it's a long way away. It's genuinely decades away. I don't think anyone is in danger of losing their job to a machine that will, spit out amazing designs in terms of architecture or engineering. However, where I really see this having a use and being employed widely is in sort of doing trivial tasks or mundane things, more monotonous things. As an example, a good friend of mine was the head of research at WeWork, and they worked on machine learning software that laid out desks in an office space. So obviously what they do is quite narrow. They hire, they rent buildings and then try and put as many desks as they can in each space, in each room. And for an architect to figure out, can I fit in 6 or 7 or 8 or 12 desks is a fairly laborious thing and not particularly exciting or pleasant. So that's somewhere where software, machine learning, can step in and sort of take over that task from a person. And that frees them up to do other much more interesting things. And I think that sort of future for engineers and architects and cost consultants and people like that, software will begin to take over those sorts of things that you find fairly dull and tedious in your day-to-day job that you have to do, but you don't necessarily love doing it. And that's where I think we'll see the real gains. And that's where it'll be interesting that sort of task that might take you a day to do will just be done in a few seconds and reliably. And then you can move on to doing other things and thinking about other things. And I think that sort of process will begin to seep in over the next 5, 10, 15 years. There will still be room for designers and creative people to think creatively.
With the robotics technology, how does the process of the robotics actually work, and what level of detail can you get to using robots to cut the timber into the unique pieces?
Yeah, I think we have to divide two things. One is the robot, and the second thing are all the other tools like cutting centers. So in the end, we don't have one tool doing all the job, but rather having an interaction between different tools. So in the cutting center, you are free to shape your timber and to get all the connections done and to have this very, very high accuracy. So you have basically a kind of a fixed installation. And the robot is in many cases used as an annex tool, if you like. So the robot might, for instance, in a setup where you start also constructing with robots, he just might merely take a piece of timber and move it from one fixed installation to the other. So this is kind of a normal arrangement. The problem is a little bit that you have to be careful about the size and weight of members you're moving around, because any weight on an arm of a robot will have or give you problems with accuracy, with positioning, and so on. So I think it's these setups which are quite interesting to look at, to have maybe some things done on fixed installations where you have all the freedom and accuracy needed, and the robot being just an extra hand and doing things a human couldn't do.
We're at Frame Australia at the moment, and yesterday you had a presentation where you had a video of your zero labour system. And I think that's, if I look at a photo or a video of what Tesla is doing in the automotive industry, it looks like they've got a lot of these robotic arms doing a lot of the automation. And this is the first time that I've seen something similar in construction. So can you tell us about what the zero labour system really does in maybe a step-by-step kind of process?
Yeah, it works in a similar way. If you're accustomed to seeing these automotive lines on TV, it sure looks similar, and it is in a way. What it does, it's based upon robotic cells. So depending on the layout or the complexity of the walls, the completion level on the walls, if you're doing closed walls or open walls or sheeted or non-sheeted, the setup will be a bit different from case to case. But it actually works a little bit like, you say, in automotive industry when you have a running belt. Yeah. So the wall comes in, and the robots do the work assigned to it. The data transfers into the robot cell, and it does the work that's assigned to the wall, and send it to the next cell. So it could be routing, sheet placing, nailing, screwing, ink marking, gluing, and that's the nice thing about the robots. There's really no boundaries. You can do a lot of things, and since they're so flexible with all these different axes that's available, we can evolve it as we go, and so can the customer, really.
Say the cost of a physical arm, is most of the cost in the actual physical material in creating the arm, or is it actually in the software, the algorithms that's created for the robot? The reason I ask is because, I'd imagine it might be cheaper in future if all the cost has been in generating the really smart algorithms, and that can be applied to a lot more, robotic arms.
Well, I think it's a balance. I mean, of course, the arms are not they don't come for free, but there's a lot of technology going into it, both in the arms and all the stuff that goes around it, the support systems and also the electrics. There's a lot of time behind the coding for sure, and that's what I touched base with yesterday on my presentation, comparing it yet again to the automotive industry, where in the car line, you have the robots are more hard-coded, you could say. They're doing tasks that's predefined, programs that's predefined and optimized in a different way that we can do it. We have to read every drawing and interpret the drawing and assign data and create programs as we go. So we are actually more flexible in that way than the automotive industry. So we need to, if we didn't, there's not a lot of house builders who will say that I have only 2 modules with 4 walls, so you can do just special programs for this and nothing else. No one wants to do that. Everyone wants to just be able to send the drawing in, so that's a very important part of it. I think in the future you will see more and more workers becoming operators, and I think that's a good thing. When I started out my work in my career, like over 20 years ago, I was a bit skeptical about doing automation because I thought that maybe this isn't a good work to have. I will take jobs from people, and I really had to think about it, but it hasn't turned out that way. Often we just come in with automation and it generally boosts the customer, so actually they hire more people because their revenue go up and they can do more things, and it's all about removing the jobs that are not good for people anyway.
I hope you enjoyed that first episode of a 4-part series where we'll be going through the archives and finding all the best content we've had on Timber Talks. If you'd like to get in touch and give me feedback on the show, you might have someone who's a potential guest that you might recommend, feel free to get in touch with me on LinkedIn. Just search Adam Jones. And I'm always happy to hear some suggestions on how I can improve the show and who to have on for season 4 in 2021.